Hi everyone, in this video let us understand what is EMR and EKS service, how does it work, what are the various benefits, and we'll also look at the demo at the end. Let's get started. It is one of the deployment options for EMR to run open source software big data frameworks on EKS cluster. And it helps the productivity for the data teams and the data scientists. Why? Because it takes care of undifferentiated heavy lifting of building, configuring, and managing the containers for open source frameworks. Okay, and the teams can leverage the existing EKS infrastructure along with other applications. They don't have to build new infrastructure. The existing EKS clusters can be leveraged for the running the big data workloads. And the service takes care of provisioning and management of the Spark runtimes very easily so that the team can focus on building the application than the environment and the infrastructure. And there are multiple tools and ways for the developer team to submit the jobs. Okay, and they can use, for example, EMR Studio, SDK, CLI, and many other tools that we will see. They can use these tools to develop and submit the jobs and track the status and also troubleshooting. Okay. Now, before we going further, let us first understand how does EMR and EC2 works. Okay, so let us say we have EC2 instances, then we have an operating system on top of it. Then we have Yarn, which is open source big data framework scheduler for resource management. And then we have the Spark runtime on top of Yarn. Then we have any specific EMR components that are required. And finally, we have applications and the dependencies. This is a typical tech stack when you run the applications on EMR and EC2. Okay. Now, if this is the case, then what are the responsibilities for the customers and for EMR service? Okay. So let us look at that. First, the customers must specify the applications and they also need to install the dependencies. Okay, this is important. The required libraries, frameworks, third party, anything that the applications requires, they have to install it. And EMR service basically runs these applications and the dependencies together. With respect to infra and the OS, it is provisioned and installed and managed by the EMR service. Okay, so the customer has to specify the applications and install the dependencies. Then the rest of the things will be taken care by the EMR service. So this is a typical flow on EMR and EC2. Okay, now let us proceed further and look at how does EMR and EKS looks like with the same tech stack. In this case, we can use either Fargate, which is serverless option, or EC2 for the underlying infra. Then we have an operating system on top of that. Then we have Kubernetes. Instead of Yarn, Kubernetes is one of the other supported cluster managers for Spark runtime. Then we have the Spark runtime and EMR specific components and the applications and dependencies at the top. Now, if this is a tech stack, then what is the shared responsibility model? Okay, with customers and the service. Okay, let us look at. So in this case, customers specify the applications and the dependencies. They don't really install any dependencies, which was the case earlier. Okay, the EMR and EKS service builds and run the containers, and these containers includes all the required runtime and the application dependencies. So this is the undifferentiated heavy lifting we are talking about. So the data team doesn't have to really worry about installing, patching these runtimes. So everything is taken care by the service. And with respect to the infra, the EKS will be taking care of, the EKS cluster will provision, install, and take care of the infrastructure. Because when you build a EKS cluster, you also have the worker nodes in terms of EC2 or Fargate, and this is completely taken care by the EKS admin team. Okay, so data center doesn't have to really worry about it. Okay. Now let us look at a comparison between the EC2 versus EKS for EMR service. So the EC2 is the EMR and EC2 is based on typical Yarn scheduler. And if you have different workloads, for example, streaming workloads is one of them, and which requires EMR version 6.x, for example, then you require a dedicated cluster. Similarly, for batch workloads, it may use the same version or a different version. Again, there is a different cluster you have to deploy. Similarly, for interactive workloads also, you need to create a different clusters. So in the EMR and EC2, for every different workload, you have to create a brand new cluster and with the respective EMR versions and all the required runtimes associated with that version. Now, in the case of EMR on EKS, the way it works is you can have one single EKS cluster, and within that you can have multiple namespaces, and each of the namespace can have a different version of the Spark runtime, okay, and different version of the EMR runtime. So that means in a single cluster you can have multiple workloads running side by side. You don't really need to create a separate cluster for each workload. So this is a big advantage from a bin packing perspective and cost optimization perspective, operational overhead perspective as well. Okay. Now let us look at how does EMR and EKS works actually. Okay. Let us say we have an EKS cluster and we have an API server, which is the control plane endpoint. Then there are two teams, for example, data team A and B, and we have to create the namespaces first in the cluster. And then we have to create a virtual EMR clusters. Okay, so virtual cluster in nothing but is just a namespace. It's just mapping to one of the namespace in Kubernetes cluster. Okay, so in this case, when the data teams wants to run the Spark application into the cluster, they first create the corresponding namespace, and they also create a virtual cluster, and they also create a corresponding execution role. Okay, job execution role. So this job execution role has the required permissions in AWS to access the various resources. Next, the data teams will be submitting the jobs. Okay, so the data teams does not really talk to the cluster EKS cluster directly. Instead, they will invoke EMR and EKS service API, and which in turn will talk to the Kubernetes cluster to deploy the Spark jobs. So the EMR and EKS will use one managed service role, and which needs to be mapped to Kubernetes or back to access the EKS cluster for authentication authorization. Okay. So using this service link role, which is already mapped to Kubernetes RBAC, now the service will deploy the Spark workloads. Let us say uh, we require Spark version 1 for data team A. Okay, it first submits a job submitter pod, which in turns create a job Spark driver, and Spark driver will create Spark executor pods. Okay, and the driver and the executor pods will use the job execution role, which is created initially along with the virtual cluster. So this is how the flow looks like. Okay. So here what we need to understand is the role which EMR service will use to talk to the Kubernetes cluster is different, which is service link role, which will be mapped to Kubernetes RBAC. And the job execution role is basically IRSA, which is basically IAM for service accounts in Kubernetes. So the executor and the driver pods use this job execution role to access various AWS services and resources. For example, it could be S3, CloudWatch, and any other required dependencies for the job. Okay. Similarly, when the data team B submits their jobs, again using the same EMR and EKS service API, and this service with using the service link role will submit the job to the Kubernetes cluster in the namespace B. Okay, and this namespace B can contain or can run different version of the Spark runtime. Okay, so team A and team B can run different workloads are with different EMR or Spark versions with the different dependencies and with a different input and output and with a different AWS service access. So everything can be completely different between these two teams. Okay. Now, what kind of workloads does EMR and EKS supports, and what are the customers typically recommended workloads? So one of them is batch processing and stream processing. Both batch processing and stream processing workloads are commonly used, and machine learning workloads are also there. Customers can leverage EMR and EKS to build and train models, and they can also run interactive queries using the notebooks. And with respect to the benefits, there are quite a few benefits. Let us take one area at a time. For example, from the cost optimization point of view, how does EMR and EKS provides benefits comparatively. The first one is simplifying the infra management. Here we are not creating a dedicated EMR cluster for every job or a business unit or a different workload. We are using a single EKS cluster where we are consolidating multiple workloads and applications within the organization. So that means we are saving a lot of cost with respect to infra management. That is number one. And then the Spark executor parts can run on EC2 Spot as well, or we can use savings plan or RI reserved instances depending upon the purchase options that customers can have different options. Okay, so it will save a lot of cost when they use Spark because Spark provides resiliency inherently, so no need to worry about Spark getting interrupted. And then EMR and EKS also support something called dynamic pod autoscaling. It's like a vertical pod autoscaling. That means changing the CPU or the memory resource configuration based upon the job requirements. So this is also another important feature uh, which got launched in the recent Kubernetes versions. And with this, they can right size the pods properly to save cost. Then the way the EMR and EKS is priced is basically pay for use based upon the CPU and the memory. For a given 1 vCPU and 1 GB, certain amount is charged. So it's only based upon the usage. Okay, so that way it is beneficial for customers to run the workloads. And the customers can also leverage some custom batch schedulers like Unicorn or Volcano for specific job requirements. This will also optimize the cost. And some of the experiments done with respect to EMR and EKS and open source Spark and Kubernetes. So there is a significant 61% reduction in the cost when compared to open source Spark. So EMR and EKS provides that kind of a benefit from the cost perspective as well because of the optimized runtime that it provides. Then the next one is basically centralized and unified data governance. Okay, so in this case, EMR and EKS supports fine-grained access control with lake formation. Okay, this is more from the security and access control. And every time there's a new software released in the open source community, within 30 days, the EMR and EK service provides the same software and with 100% open source compatibility. So that way, customers can keep up with the latest releases in the open source without getting outdated. Another big one is on the performance. Okay, and some of the experiments again showed there is a 68% improvement when compared to open source Spark because of the optimized runtime. Okay, and the optimized performance with respect to Amazon S3 as well. Inherently, the high availability and the failover is provided because EKS clusters can span across different AZs. The worker nodes can spread across different AZs, and that the resiliencies are automatically included in the service. It also supports the native NVIDIA Spark Rapid integration for better performance for certain workloads. And the clusters can start up and auto scaling happen very fast compared to EMR and AC2 because we are using Kubernetes native auto scaling like cluster autoscaler Carpenter, and also for the pods we will be using HPA or vertical pod auto scaling, which are quite performant. Then from the user productivity point of view, the developers can run various interactive workloads. They can use EMR Studio or Jupyter Notebooks. Different options are available for data scientists to run the workloads. And there is a Spark UI inbuilt into the EMR and EK service, so the developers can view the job status and debug, and all of that is available through Spark UI within the EMR console itself. They don't have to really manage the Spark UI themselves. It's completely managed offering. And with respect to native integration, we can use step functions or managed Apache workflow service, Redshift and other Glue, Catalog, many other integrations are available natively with other AWS services. And for monitoring, we can use Prometheus, Grafana, S3, CloudWatch. All these monitoring tools are available for improving the productivity for the developers. Now, let us take a step aside and look at from different persona angle. Okay, so what type of persona can interact with EMR and EKS service? First of all, the data engineers are the data scientists. Okay, from their perspective, EMR and EKS provides very optimized and very efficient runtime, which improves the performance and reduces the cost. Okay, that's important. And the data team can run interactive workloads using multiple tools. They can use the EMR Studio or self-managed notebooks as well. And fast startup time is also important because they can run their jobs very quickly. They don't have to wait longer time to bring up the or warm up the clusters. And lot of debugging and monitoring tools available natively. And their data is isolated because they're running different versions of the EMR cluster in different namespaces with respect to with the different execution roles. And so that means they have data isolation as well. Now, from a cluster admin or a platform engineer's point of view, let us understand how does it work. So basically, EMR and EKS provides a simplified management and with app consolidation because we are using the same infra for the based on EKS for many different applications. And it's easy for doing the patching and maintenance. EKS is a managed service, and when they patch the worker nodes for EKS, so it is taken care for all the applications. They don't have to do it, per application because every application is running on the same cluster. And there is a fine-grained access control with the lake formation, which is also from a security and access control point of view, it's supported. And they can benefit from the faster scaling, cluster and auto pod scaling, which are based on Kubernetes native, features. And by default, it provides multi-age resiliency because Kubernetes clusters are built around multiple edges. Now, to submit the jobs, what are the different options? So customers can use the CLI, the command line interface. They can use SDKs, for example, Boto3 SDK they can use. They can use a Spark Submit APIs directly to the Kubernetes control plane server. They can use AWS managed workflow for Apache Airflow. It's a managed service. Or they can use Spark operator also to run the jobs. They can use EMR Studio and they can also use the step functions. So there are a variety of tools and methods customers can use to submit the jobs depending upon what they're comfortable with. And EMR and EKS supports multiple open table formats. So one of them is Apache Iceberg, another one is Apache Hudi, and another one is Delta Lake, open source Delta Lake. So multiple options are available. Now with this, let us go through the lab and run few Spark applications on EMR and EKS cluster. Let's get started.